All right, we're in section 10.2 where we're going to find arc measures. So again, just like in 10.1, we have some terms that we're going to look at that have characteristics of for circles. The first one they have here is the central angle. So the central angle is the angle in which whose vertex is of the center of the circle, and then in this particular diagram is considered to be angle A C B. And you got to remember that this middle value here must be the center point of the circle. Okay, so A C B. All right, so it could have been BCA if you would have chose to do it that way. The next thing we're going to look at is the minor arc. All right, the minor arc is formed in this case with the points A and B, and it's this arc right here. So, and the minor arc is also has a degree measurement, and we're going to talk a little bit about that in a sec. But the next term we have is major arc. All right, the major arc in this case is right here. So when you have endpoints, it get broken up into two parts. It's either the major arc or the minor arc. So when you are talking about the minor arc, you only have to use the two endpoints to establish or call it by name. So in this case, it's A, B, arc A, B, and you put the little curve on the top to let you know that it's the arc. And so you only need 2 points to establish the name of the minor arc. For the major arc, you have to have that third point there. So in this particular instance, it's going to be A, D, B. And so to talk about a major arc, you need 3 points. So that's the difference when you're talking about naming uh, the two different arcs. And then the last term should be pretty familiar with. It's semicircle, which means semicircle is half the circle. Which means we're talking about an arc with endpoints that would be considered the diameter. So let's say if I made a line here, we'll call this X, we'll call this Y, and we know that it goes through the center point C. So, we could say that arc XY is a semicircle, or XDY or something like that. Okay. Looking down here, it's it says measuring a minor arc. So when you're measuring the minor arc, we can find the minor arc is the measurement of the central angle. So if our central angle here is 50 degrees, the arc is also going to be 50 degrees. Now measuring the major arc is going to be the difference between 360 degrees and the value of the minor arc. So if you ever, a circle is 360, so that's where they get that from. So that's where we can take 360. In this case, we subtract it by 50, so we know that the major arc is 310 degrees. So in this example here, they want us to find the different arc measures, and they're telling us that RT is the diameter. Okay, so that does help us. Looking at this, we can still use a lot of our prior knowledge from other chapters in geometry and say, okay, well, we got point C here is the center, and we have this line segment here, and I realize that from here to here is a linear pair. And I know that everything that's with linear pair, the sum is 180 degrees. So I could say that 180 minus 120 is going to give me 60. So that's where I can get that value right there. And that's how I can now know that the minor arc of RS is also going to be 60 degrees. Next, we need to find, it says RTS. So I'll just kind of draw it out. So RTS. So basically what that is everything that's in green is everything that's not part of that 60-degree central angle. So I know I could take 360 and subtract it by 60, and that's going to equal 300 degrees. Finally, I can look at, it looks like I got R, S, T. And we could also assume because we know that RT is the diameter, we know it's a semicircle, it's going to be, half of 360, which is 180. But we can also prove it that we got two central angles here of 60 plus 120, and that is also going to give us 180 degrees. One of the last things we're going to look at is looking at congruent arcs. Congruent arcs need two things. First, they need to be the same central angle. And second, it has to have either the same radius or diameter. So they have to be congruent in all of those phases. So for this first one, they have the same central angle, 145, 145, but they also have the same radius of 4 and 4. So yes, these are congruent arcs. Now, this one here, yeah, they do have the same central angle of 87 degrees, but one is a radius of 7, the one is a radius of 3. Because they're not the same radius, these are not congruent arcs. And that is being able to find arc measures. Hope this helps. Until next time.